Welcome to the Explainer. Today, we're going to break down a foundational concept in software development, the waterfall model. Think about it like this. You can't paint a room before the walls are even built, right? You have to build the frame, then put up the drywall, then you can paint. There's a sequence. That simple step-by-step logic is the absolute key to understanding the waterfall model, which was really the original blueprint for how we build software. So the official term is a linear sequential lifecycle model. Now, that's a mouthful, but it tells you everything you need to know. It's a straight line. Each phase has to be 100% complete before the next one can even start. And just like a real waterfall, there's no going back upstream. So where did this super structured idea even come from? Let's take a look at its origin. All right, let's go back to 1970. This model was introduced by a guy named Winston W. Royce. You have to remember, back then, software development was kind of, well, the Wild West. Royce came along and proposed this structured approach to manage these huge, complex projects with a clear, predictable plan. It was all about bringing some much-needed engineering discipline to the whole process. Now, it gets its name, waterfall, from its process, which only flows in one direction, downward. There's no going back up. So let's walk through the steps. The whole thing is broken down into these 6 very distinct phases. First up, you have requirements, where you gather and document absolutely everything the customer needs. Once those are locked in, you move to design, where you create the system's blueprint. Only then do you get to implementation, which is, writing the actual code. After that, testing makes sure the whole shebang works, followed by deployment to the customer. And finally, you have the maintenance phase for fixing bugs later on. The key thing is, the output from one step is the non-negotiable input for the next. And this really illustrates the model's defining feature, its absolute rigidity. All those requirements, they get locked into a formal document called a Software Requirement Spec, or SRS. Think of it like a contract. Once that thing is signed off, it's pretty much set in stone. So, given how inflexible this all sounds, you're probably asking yourself, why would anyone use this model today? Well, it turns out it absolutely shines in some very specific situations. The waterfall model is perfect for projects where you know the final destination with total certainty before you even start. Think about building a bridge. The laws of physics aren't going to change halfway through construction. Or maybe you're building a simple internal tool based on fixed government tax codes. If you know exactly what you need and you're confident nothing's going to change, this super structured approach can be incredibly efficient. But, and this is a really big but, that same rigidity that's its greatest strength in the right context, it's also its greatest weakness. So what does happen? This is the question that really exposes the model's biggest flaw, because in the real world of software development, change is pretty much the only constant. A competitor might launch a new feature, the market can shift, or the client might just realize, oops, I forgot something really important. And once you're deep into the implementation or testing phase, trying to go back and change a fundamental requirement is, well, it's a nightmare. It's incredibly difficult and ridiculously expensive. Because everything is built in that strict sequence, a change at the top creates a massive domino effect that can literally derail the entire project. You can see the central trade-off right here. On the one hand, yeah, you get simplicity and control. The stages are clear, the deliverables are defined, and it's easy to manage. But on the other hand, you sacrifice all flexibility. Change is nearly impossible to accommodate, and you don't even see a piece of working software until the very, very end. That means you're carrying a huge amount of risk until the final stages. And here's a look at the consequence of that risk. Because all the testing happens at the end, any bugs or defects you find are much, much harder and more expensive to fix. It's so bad, in fact, that on some projects, up to 60% of the total effort is spent in that final maintenance phase just fixing issues that were locked into the design months or maybe even years earlier. Okay, so if the model has such huge flaws for how we develop things today, why is it still so essential to learn about? Well, Waterfall's legacy is profound. It was the very first model to suggest that software should be built with discipline and a plan, not just coded chaotically. It introduced the foundational idea of define before you design and design before you code. Every modern software development model, even its total opposite like Agile, owes a debt to Waterfall. They were all created either by building on its ideas or by reacting directly to its limitations. Understanding Waterfall helps you understand the why behind all the other methods that came after it. So the key takeaway here is that Waterfall isn't just some outdated model from a textbook. It's a foundational lesson in project management. It really demonstrates the power of having a clear plan while also teaching us a very valuable lesson about what happens when that plan can't adapt to reality. And that kind of leaves us with a final thought to chew on. And this applies to any project, not just software. When does a disciplined plan stop being helpful and start becoming a roadblock? The answer to that question is really what continues to drive innovation in how we build things today.